Concept 3, using properties of exponents to simplify expressions. Alright, so if you remember back to last year in chapter 4, we looked at exponents and we looked at some of the properties of them. And one of them that we looked at was when you have a base raised to a power and then that raised to another power. Okay? And we looked at the fact that doing so basically had the effect of multiplying the two powers together. Okay? And so if I have a to the second, that's a times a. Okay? And if I do that 3 times, that would be a times a times a times a times a times a. Right? And I get my 6. Right? I kind of have a block of 6. Okay? So we're going to use that to work on some more complex problems and try and simplify those. So in this problem, I have a fourth root, right? And I have a fourth root of a squared times b to the fourth. All right? And I can separate these out. Because it's just multiplication, I can separate this out into the fourth root of a squared times the fourth root of b to the 4. Okay? And you can also remember that these roots, right, these fourth roots, are basically just fractions. Okay? So this is going to be basically a to the second raised to the 1/4, right, times b to the 4th raised to the 1/4. Okay? And now my property of exponents starts to kick in and be really useful, because if I have, in this case, 2 times 1/4, well, that'd be 2 over 4, or just a to the 1/2. Okay? So I'm going to have a to the 1/2 times, well, b to the 4th times the 1/4 is going to be 4 over 4, or just b to the 1st, or just b. Right? So I've simplified this down to a to the 1/2 times b, or, just to write it differently, the square root of a times b. Okay? Let's look at a real complicated one. All right. Now, again, you want to remember, if it's multiplication or division, you can break it up into little pieces. Okay? And that always helps. So here I've got the square root of x, and that's going to be to the 5th, and that's times y to the 3rd, and that's going to be to the 5th, right? And over here, I'm multiplying that by the 3rd root, or the cube root of x to the 6, times the cube root of z to the negative 2. Okay? Square root is the 1/2 power. So I have x to the 5th to the 1/2. And I could do this the other way. I could say it's x to the 1/2 to the 5th. It shouldn't change my answer at all. Times y to the 3 times 5, or 15, times the cube root, I'm going to rewrite that, right, times x to, well, we'll move it opposite of the way we did for this one, x to the 1/3, because it's a cube root, to the 6th power, times z to the negative 2 to the 3rd power. Okay? And you can see I can do it whichever way I want. And now I'm just going to be making my fraction, basically. So x to the 5 times 1/2, or x to the 5 over 2. And you always want to keep it as that fractional exponent, you would never want to change this to x to the 2.5 power. Okay, always keep it in that fraction, because then you can split it up into, if I'm plugging a value in here, I could split it up into, x to the 5th to the half, or the square root of x to the 5th. Okay, multiply that times y to the 15th. And then here I've got x to the 1/3 to the 6th. 6 over 3 is 2, so x squared. And over here I've got z to the negative 2 to the 1/3, or z to the negative 2/3. Okay, and yes, this is a really long, complicated question, but I wanted to make sure I get all the different types of problems that you're going to run into. Okay, now I'm going to start moving things around. My y, I've just got one y, so I'm going to pull it over here. I'm going to have it first, y to the 15. Okay, and then I've got x to the 5/2 times x squared. Okay, and if you remember your other properties of exponents, if I have a to the 3rd times a to the 4th, that's going to equal a to the 3 plus 4, okay, or a to the 7th. All right, and we're going to use that pretty soon. And now this one, I am going to use the fact that it's negative. All right, remember that property, and get my z down below. So it was negative 2/3. I made it, I flopped it, right? I flipped it upside down, and it's going to still be the positive 2/3. I should really put a line on my z's so I can keep them separate from my 2's. Okay? And then the last step to finishing this problem is to add these exponents. Okay? 5/2 plus 2, or 4/2. 5/2 plus 4/2 is going to equal y 15 x to the 9 over 2 over z to the 2/3. Okay, and that's probably a more complicated problem than you'll get in this lesson, but again, this covers pretty much everything you might have to see, so this was a good example.